and I will allow you to share the screen, so please do.
Okay. So it should be
Almost.
now visible.
Yeah, it is. Okay. Yeah, take the floor.
Okay. Yes, thank you. So, good morning. My name is Yaroslav Boris, and today I will present the results of the research on the topic Intelligent System for Recognizing Artistic Styles, a deep learning approach. So, the goal of this research is to develop a system for classifying image styles and further study obtained models. But what is a style itself? It's a set of colors, compositional elements, drawing techniques, and other factors. Traditionally, defining style was the prerogative of an art historians because it's a long and complex process that requires a great amount of knowledge. So, why do we need such a system for style classification at all? The thing is that in recent years, the numbers of both artists and digital art has increased dramatically. And in the following years, it is expected to grow even more. This whole volume of images includes those created in dedicated programs, and of course, those created by generative AI. So, with such a great amount of images, we need a way to classify all this thing and to help us deal with it. Now, the applications of such system are quite numerous, and among them are art and cultural studies, museum and galleries, digital archives in education for further development of artistic knowledge and so on, and of course commercial applications, creating filters in digital art, helping all the recommendation on different platforms, etc. Now, this whole theme is not a new one, so there's already some research on the topic. But the thing is, most are purely theoretical. For example, the first article, it describes a new approach to obtaining features from the styles and trying to analyze them further. But it's that, just theoretical. And if we are talking about practical approach, then for example, the last article, yeah, we have a quite nice accuracy of 95%, but the thing is, only two styles, realism and naturalism. And of course, there are already created products. The first of them is Art Style Identifier AI, the second Art Style Explorer. Those two use LLM models to classify the images. And the last one, NACL, well, it's not really a style classification, it's more genre classification, but it helps to uncover the compositional elements, so I included it here. Now, for the fun part. This study used the WikiArt dataset containing over 1,000 high-quality images, which are already divided into 27 styles, as can be seen on the left plot. For the training itself, 5 classes were considered, namely abstract expressionism, color field painting, mannerism, late Renaissance, naive art primitivism, and post-impressionism. And 1,000 images were used for each style. Now, of course, there's also the split for training and validation, namely 80-20. Now, the developed CNN architecture is quite simple and consists of 4 convolutional blocks as shown on the picture on the right. The first has 16 filters, followed by 64, 128, and yet again 64. Every filter is size 3 by 3. And for better accuracy, data augmentation was also applied, as shown on the picture on the left, namely rotation, reflection, and scaling. Here are shown the very first iteration on the top of the screen, and then the last iteration on the bottom with the best results. So what's happening on the first iteration? It was just CNN architecture without any data augmentation, without any regularization techniques. And we can see that there is quite severe overfitting with validation loss of about 1.2 and training loss of about 0.1. Now, using regularization L2 with a coefficient of 0.01, we were able to briefly, I'd say, make the overfitting smaller. It's still present, but it's a bit better result with a training accuracy of around 0.7 and the validation accuracy of about 0.6. Now, about the confusion metrics, we want to know how the model determines and works with each style. So, as can be seen, the model learned three styles best, namely, they are here represented by the labels 1, 2, 4. But in name, they are color field painting, mannerism, late Renaissance, and post-impressionism. Abstract expressionism, which is labeled as 0, is often confused with color field painting, labeled 1, because these styles are both abstract. And surprisingly, the model practically did not learn naive art primitivism, which is labeled here as 3. For the sample of usage, also an interface was implemented. It consists of three main elements: the place where you can load the image, the place where you can load the model, and of course the place for the results. And now, can this model further be improved? Yes. The first is to change the CNN architecture, namely to add 1x1 filters to capture local features. Because while 3x3 is quite balanced, it may miss some smaller objects or larger objects. The second way is to implement ensemble. And for example, or even to study styles like teaching how to distinguish. Sorry. Uh, the way to implement this ensemble can be like each model will learn two styles, its own and the combination of all others. Then it just can combine the results. And the last option is to use transfer learning on pre-trained models like VGG16, 19, exception, and others. Because in the studies shown earlier, those articles that use pre-trained models tend to have higher accuracy. And that's all. Thank you.
Thank you, Yaroslav, for the presentation. Well, I have some questions, but maybe my colleagues will start first. Well, while they are gathering the questions, can you go for the probably Yaroslav for the second slide, if it's okay with you?
This one.
Yeah, this one. I do remember how I was taught to present my scientific to my PhD thesis. Maybe it's not the matter in this. It's not an issue in this exact time. But the goal. I was taught that it's not to create something, but to improve, let's say, someone's life by creating some maybe information technology or something like this. So, well, I was given a short note that not to develop a system for determine this style, but to improve someone's life by developing a system for determining the styles of work and so on. So this is something that well, I was asked something like this, and I understood that there's supposed to be the goal is to improve something in our power is to create some information technology, and this is something that I'm asking all my students and all my colleagues and all those who present the work to make sure that the goal is take care to make sure what exactly your goal is. And practical value, what about scientific value, Yaroslav, of your research? Practical, I can see. What about the scientific value?
Well, the scientific value is mostly finding new ways to determine the style, trying to understand which techniques use best. Because,
Mm-hmm.
for example, right now it's just basic CNN, but what
Yeah.
if it's more quite For example, the study can be further, say, there can be further research on such topic.
Mm-hmm.
Some already was discussed, like using transfer learning. But what if we can, for example, use simpler techniques like decision trees? then of course we will have to use our own feature extraction methods, maybe extracting main colors, maybe extracting textures using LPB. But the thing is that this study, apart from uh, helping people and furthering improvement of style recognition by creating system, we can also explore the best techniques to do such thing. And this is basically the scientific value.
Scientific value. Okay, thanks a lot. Well, okay. I have to tell this.
Yes.
It used to be, not sure how it's now, that again, while I was defending my PhD thesis long ago when the dinosaurs were bypassing my window, it was so far away from now. The scientific value was there are very strict there are very strict mathematical abstractions. What can be the scientific value? Scientific value, it can be either model of something or the architecture of a system or method of something. Practical value, yeah, the software developed or an algorithm of something. So maybe in PhD thesis, I'm not saying in here, just in PhD thesis, methods, architectures, and models are the scientific value. Algorithms and software applications, some information technology are the practical value. It's just in of my experience. You might want to use it someday somehow. So thanks a lot, Yaroslav, for the presentation. Maybe my colleagues have questions, those of present in here.
Yeah, I have the one. So first of
Please.
all, thank you, Yaroslav, for your work. So I'm actually curious about training data set. I don't know, maybe I miss it because I'm still trying to catch up. But what was the training data set? So
It was
how
the
was you able
WikiArt.
to find it? Okay, so it was
Well,
WikiArt. Okay, I see.
yes, it was WikiArt. Many researchers use it, and many articles describe it. So I said, well, if it exists and it is quite well regarded, why not try it myself?
Okay, and then when you display that exemplary application, so on later slides, so you used some validation subset of that data set, or it was just pick up randomly from, I don't know, like from web.
This particular example is from the validation subset, but
Okay.
what I did, as I mentioned earlier, every style, the whole dataset consists of 1,000 images.
Okay.
100,000 images, and from all that set, in my training, for both training and validation, I only take 5,000.
Mhm.
So I have a great pool of images to then take some random and see if my model can work on absolutely new images without knowing
Whether
them.
it can generalize well.
Yeah.
Sort of. Okay. Yeah. So thank you. Sorry, I missed that point, but yeah, great. Thank you for your explanation.
Thanks, Dmitry, for the question, and Yaroslav for the reply. Maybe more questions? I like this visualization very much. Thanks a lot. So maybe if there is no more question, or if there will be.
I would like to.
Yeah, please do.
Yeah. So my question is, first of all, thank you for your presentation, and I would like to ask about the training of your model. Actually, what hyperparameters did you use, like learning rate, maybe optimize that you were using during your training?
Yes, so they are both pretty much the default one. For optimizer, it was the Adam optimizer with learning rate 0.01. Regularization F2, it was also 0.01. And the batch size There were some experiments using 32, using 64, but due to limitation of my laptop, I ended up using 32. Maybe using others would be better, but yet again, limitations, overheating, and it crashed several times, so I had to make smaller ones. Even if the final accuracy could have been better.
Okay, I was just curious about like batch sizing and learning rate. Thank you for your answer.
Thanks again, Danilo, for the question, and Yaroslav for the reply. Maybe more questions? Okay. If not, well, Yaroslav, thanks a lot. It was difficult to be the first, but you did it, and you did it well. Thanks for your presentation. Thanks for your report. Yep, the next presenter is on the work of continuous categorical feature dependence with determination-based correlation coefficient. Andrei Burgo, I saw probably Vladislav Holdovansky. Is it Vladislav? Yeah.
Hey.
And for the future, can you please switch the camera on so we could see you? It would be very interesting if we could see the presenter. And
Hi.
oh, hello, Vladislav. Nice to see you. Okay, you can start sharing the screen anytime. Oh, yeah.
Do you see?
Yeah, we can see it. The first slide. Very good. Take the floor.
So, greetings to the Eastern Committee and audience. My name is Vladislav Holdovansky, and I'll present our work, continuous categorical feature dependence with determination-based correlation coefficient. So let me start with the motivation behind our research. In many classification tasks, datasets contain both numerical and categorical features. While several traditional methods exist, such as ANOVA, point serial correlation, or mutual information, they all have limitations. These include strong statistical assumptions like normality, limited interpretability, and limited support for multi-class classification. So our objective is to explore the DBCC approach and apply it to classification tasks. Specifically, we aim to analyze how DBCC behaves under different types of dependencies between feature and labels, compare it with existing dependency detection methods, and evaluate how well algorithm can approximate classification metrics. So what is DBCC? The determination-based correlation coefficient estimates how strongly a feature determines the target feature. It works by discretizing the input feature into a grid and measuring how consistently each region corresponds to a target. To do this, we introduce the grid, which calculates local variances within each segment of the grid. These local variances are then compared with global one to quantify the strength of the relationship. This approach allows us to approximate the coefficient of determination, even in nonlinear settings. This method is interpretable. DBCC produces results that are straightforward to understand and explain even for non-experts. It's fast to compute. The method is computationally efficient and requires minimal processing time, even on large datasets. This speed makes it ideal for early stage analysis, repeated computation, and interactive data exploration. It's model-free, so DBCC does not rely on fitting a predictive model. It can be applied directly to data. It naturally supports nonlinear relationship. DBCC can detect complex nonlinear associations between variables. This allows analysts to uncover hidden patterns and dependency that traditional method might miss, especially in high-dimensional or real-world data. Additionally, DBCC is bounded within 0 to 1 including, and can be interpreted similarly to the coefficient of determination, as the proportion of variance in the target explained by the input feature. This makes it especially useful for exploratory data analysis and machine learning tasks, where understanding how features explain the outcome is essential. We tested DBCC on synthetic datasets with various types of dependencies between a continuous feature and categorical labels. Here are some examples. A step function where each interval maps to one of two classes, a double step function where class labels alternate more than once, a multi-class step function with three distinct class segments, a sigmoid function which approximates a solid boundary between classes, and a case with no relationship at all. You can see the coefficient result on the slide. In all of these cases, the BCC successfully detected the strain of dependency. We then compared the DBCC with methods like mutual information and point-based serial correlation. The table indicates that the DBCC method outcomes other in several key aspects. It's linear computational complexity, meaning it can scale better with larger data sets, lower sensitivity to data distribution, which allow it to perform well without strict assumption about how the data is distributed. Great interpretability, enabling analysts to easily understand and explain it to non-technical people. Normalized output in 0 to 1 inclusive, what makes it easy to interpret and compare, and allows vector input, offering potential for improvements. We also propose to use the grid-mean algorithm to approximate classification metrics. This algorithm serves as the core computational mechanism underlying the DBCC. The algorithm estimates metrics like accuracy or log loss with a typical approximation error below 0.05 for sigmoid function on synthetic data with different noise levels. This is promising for application where fast model-free evaluation of features is needed, such as in data feasibility, feature selection, automated data analysis, explainability tools, etc. To summarize, DBCC is simple, fast, and interpretable method for analyzing feature label dependencies. It can effectively handle nonlinear and multi-class relationships. It enables approximation of classification metrics without any model training, and it may serve as a powerful tool for future analysis in practical ML flows. In the future, we plan to improve the accuracy of grid-mean algorithm, metric approximation, extend DBCC to handle multivariate inputs, not just a single feature, and apply it to real-world high-dimensional datasets. Thank you very much for your attention, and I'll be happy to answer your questions.
Yes, Ladislav, thank you for the presentation. And yeah, we are waiting for the questions. Meanwhile, I will definitely ask about the scientific value of your research, but it will be later after all the other questions, maybe. Or if not, maybe we shall start from the scientific value. What is the scientific value of the research, of your research, Vladislav?
First of all, determination-based correlation coefficient allows us to analyze nonlinear dependencies. So it's essential for data analysis. In reasons that there aren't so much methods that work in all cases. They're usually method which works in some special conditions only. So it's why important to develop some universal method for all cases.
I see. Okay. Yet again, scientific value. It's but maybe I'm in my very far away kingdom past. Okay. Thanks a lot for your reply. And how do you say what would be the practical applications of the results of your research?
It's like another correlation coefficient in another relationship measures. It's to analyze how two features is dependent between them.
Yeah, okay, but how can we use the results of your research? Well, you will find what depends on what and so on, and you will create what. How do we use it in everyday life? Who can use it in everyday life?
Data analysts, data scientists, and machine learning engineers can use it. So first of all, it's again correlation analysis, and Second one is this future lava method that we can approximate classification and regression metrics. So it's useful for machine learning engineers to analyze data sets and their potential on early stages of ML projects.
Yeah, okay, I understand. Thanks a lot, Vladislav. Maybe more
Thank you.
questions? If not, yet again, you can reach us in the chat, so I will transfer your question to Vladislav or ask the conference organizer. Thanks a lot, Vladislav, for the presentation. Thank you very much. The next presenter is supposed to present on the matter of mathematical model of a decision support system for identification and correction of errors in Ukrainian text based on machine learning. Rostislav Fedchuk, yeah, I can see you. Oh, hi.
Hello.
Hello.
Wait a minute.
You can.
I cannot share. I don't know why.
Try. Well, we have already experienced that it's possible, so.
Wait a minute, sorry.
Okay, take your time. Meanwhile, I will remind all of us that at 11:30 it will be the round table and the closing ceremony, and you might want to join. If we will finish earlier, then we will stop the meeting and then come back at 11:30. And here's Rostislav is back. Just a second. We will welcome him in. Back.
Sorry for this. I need to
It's okay.
give access to
Yeah,
share it, so to reconnect.
of course.
Yeah. Right now it should be good.
It started. Then
What do you see right now?
I can see your browser.
Oh, sorry. Desktop.
It was probably permission issues, right?
Yeah, exactly. So can you see the
mathematical?
Yes,
Yeah, we
your
can
presentation.
see.
Yeah, thanks.
So
That's great.
take the floor.
Okay, so let's get started. So today I'm going to present mathematical model of a decision support system for identification and correction of errors in Ukrainian texts based on the machine learning. So let's go into it. So in today's rapidly growing text content, the problem of automatic text verification and correction is becoming particularly urgent. And for the English language, though many studies have been conducted, however, for the Ukrainian language, there are still a lack of sufficient research that would consider our complexity of Ukrainian language is morphological structure, dialect diversity, syntax, and so on. And errors in text can be different nature, spelling, grammatical, punctuation, semantic, and so on. And in different errors depends on different rules, and we need to consider this when creating our system. So the purpose of the research is to develop a mathematical model of decision support system for identifying and correcting errors in Ukrainian language text using machine learning. The object of the research is a process of automatic identification correction. The subject of the research is a mathematical model and machine learning algorithm that allow solving classification and generation problems for building an effective text processing system. So speaking about research task, it was to formalize the process of text analysis, building models as consider morphological syntax and other complexities, build DFD diagrams, and create algorithms for detecting errors and correcting them. Traditional grammatical error correction systems are typically built on a set of linguistic rules formulated by experts and dictionary databases. Such system checks spelling, but there are no not so efficient. The complexity of grammatical dependency of the Ukrainian language imposes numerous limitation on such system. Speaking about more sophisticated systems, it's SMT is statistical machine translation. They is better, but is more flexible approach, but the basis of Tash models is analysis of large corpora of text, and using this approach has some advantages, but in general they are also limited. Modern automatic text correction tools have become an important nowadays, and we have Grammarly, and is one of the most popular, but however, it's not supporting Ukrainian language, and but it's created UA guess corpora, and this for now is the only one that we can use for learning our models. It's only for Ukrainian language, and that have errors and corrected text. Also, we have GPT tools, is Ukrainian desktop application based on GPT-4 artificial intelligence. We have language tool, which supports multilingual formats, including Ukrainian, but it's based on rules. And as we mentioned previously, those systems are limited. And every time we need to add some more rules to it. Also, we have Vector, and what is more important, Hugging Face, that is a platform that where we have a lot of models, and we can use them to learn on some different data sets, and online corrector. So decision support system for identifying and correcting errors is based on the use of natural language processing and machine learning methods. The system consists on three main models: identification model, correction model, and the machine learning model. An important aspect is the ability to integrate additional components such as lexical databases, semantic networks, and algorithms for increasing the accuracy of the analysis. In this slide, you can see the stages for a identification model. First of all, is preprocessing of text, analysis of the semantic and morphological structure, creating a language model for context analysis, selecting candidate tokens for corrections, and then filter these candidates and choose for sure which tokens we need to correct. On this slide, you can see the algorithm of selecting candidate. We need to do lexical analysis, grammatical agreement analysis, punctuation analysis, statistical frequency, and contextual inconsistency. Also, a lot of formulas were created during this and used during this research. You can see the formulas for the input data, output data, the set of error classes, the task of finding the optimal candidates, the cross entropy, and so on. For the correction criteria, we use accuracy, quality, error rate, recall, and F1 number. So let's move further. On the next slide, you will see the data flow diagrams for the level 1 for identification model. We have user and the output of it, the text list with tags and error types. This diagram you can see in more detail that we have also a dictionary, can use rules, and the other stages that I mentioned previously. On this we have even in more detail text normalization, tokenization, stemming, or lemmatization. Also, we have another level 3 diagram for POC tagging, which includes POC tagging, building a syntax tree. On this, we can see also the stages that I mentioned previously, but in a diagram. This one is for error correction model, which takes everything that produce identification model, and the output of it is corrected text. Here you can see in more detail this correction model that we have candidate generation, choosing the optimal candidate, and formatting the corrected text. So the machine learning algorithm includes model initialization, data preparation, the learning process, validation, and testing. Speaking about fine-tuning, the study, the embarked large 50 from Facebook was chosen for the task of automatic error correction. And here you can see the hyperparameters that were used. There were two iterations. First for free epochs, batch size 4, maximum token 64, and learning rate. So the second iteration, the same actually, but with less learning rate. And you can see the diagram how it was. Of course, it would be better to have more epochs and to increase all the hyperparameters, but the limitation of the local resources. So we have what we have. Here we can see the how it was, the training itself. And here we can see the training validation losses and the metrics, Blue and Meteor. So we can see that for the free epochs it was the best, and then it was slightly better, but the free epochs is the best. On this slide, you can see the how it works. So we have the original text and the corrected text. So summarizing in graphs, we can conclude that the chosen approach to training the model is effective. So high indicators are good, but of course it can be better and better every time. But the rapid growth of metrics between the first and second approach indicates that even in a short training time, the model can do something good. Yeah, and the conclusion, we can say that we need to create even more and bigger corpora for error correction for Ukrainian. Your guess is only one, and it's not big enough to create like models that can correct all the errors that we need. And the result of the work is develop a mathematical model of decision support system that focused on the implementation of machine learning approaches. As a result of the approach, mathematical basis was formulated for solving the task set, including the formulation of the data flow, the placement of system components, and the presentation of text in the form suitable for machine processing. The model was trained, as I mentioned, on UGS corpus. The results show that the simplest and even some more complex cases were corrected. That's pretty much it from my side. Waiting for your questions. Thanks.
Thank you, Rostislav, for the presentation. Very interesting. And yeah, questions, please.
Thank you, Rostislav. And actually, yeah, I have a question regarding model. So you mentioned that you used Facebook MBART model. So the first question is, how big is that model? So in terms of parameters. And the second is, have you tried like using different some other methods models? And why exactly you chose this one?
Thanks for your question. So as you can see, I use large embark model. So we have base, and if I don't mistake, small one. So I don't know exact amount of hyperparameters, but it's billions. So it's pretty much big model, and that is why it was trained for a couple of epochs and not big enough batch size, and so because local resources cannot do it. I choose it because it's we can this model has Ukrainian. It's trained also on Ukrainian. It's multilingual, and which means this M in BART, and that means that we can set the Ukrainian language and understand it. I tried different models. It was less better than this one.
But was you able to fit it into your laptop, or you use some external resources?
I use
computational resources?
I use Collab. Also, I used Kaggle, I guess, if we name it right.
Yeah. So the model was fine-tuned on that, in cloud, right?
Yeah, exactly. So it was
Okay.
in cloud plus my resources. It was combined.
Okay.
Yeah.
Thank you.
Thank you.
Thanks, Andriy, for the question, and Rostislav for the reply. And I have a question. No, just a small note. Can you go back to the slide where the tasks were enlisted? At the very beginning, almost.
Sure. Yeah.
Yet again, as I was taught, if the research tasks, let's say 4 of them, in the conclusions, there are supposed to be 4 or more results, which will said, we formalize the process of text analysis by something. We built a model. So if there were 4 tasks, there are supposed to be 4 or more results in the conclusions. It's just the formal matter. Okay, so just
thanks.
keep it in mind. Okay, maybe more questions for Rostislav? Yes, if no questions, Rostislav, thanks a lot for the presentation. Thank you so much for joining us. And we're a little bit behind, no, a little bit above the schedule. And the next presenter, I can see Andriy Vasilyuk. Yeah, very good. It's the presentation on development of a microcontroller-based climate control system using neural network technologies. You can, we can see the screen. It's shared. Take the floor.
Okay. So, good day, dear colleagues. For your attention, we present a report on the topic development of a microcontroller-based climate control system using neural network technologies. Okay, so next. Yes. Modern climate control automation increasingly relies on artificial intelligence and neural networks. And optimal indoor microclimate boosts comfort, employee productivity, and equipment longevity, which is vital for business. Traditional systems regulate temperature and equipment and humidity mechanically or pragmatically, but modern adaptive systems use real-time data and machine learning to predict and adjust climate conditions based on environmental changes and user preferences. The growing demand of energy efficiency and comfort drives the development of intelligent systems. Neural networks enable smart climate solutions that integrate with IoT devices, optimizing energy use and supporting sustainability. These innovations support sustainability, reduce maintenance costs, and aid in smart city development by lowering emissions and improving resource use. In recent years, automated climate control has gained significant attention due to advances in microcontroller technology and artificial intelligence. Neural networks enable adaptive systems that optimize microclimate parameters based on environmental changes and user needs. Current research focuses on 3 main areas: classical control algorithms, fuzzy logic, and neural networks. PID controllers offer stability but lack adaptability. Fuzzy logic considers user behavior but requires precise rule configuration. And other things you can see on this slide. The analysis of current climate control solutions relies 2 main approaches: traditional system using classical regulations algorithm and modern system based on the machine learning and neural networks. Traditional systems maintain environmental stability but lack adaptability to changing conditions. They're mainly applied in industrial and commercial settings where stable parameters are essential. In contrast, AI-based systems, especially those using neural networks, offer adaptive climate regulations. This system can analyze historical data, predict changes, and adjust operations in real time, demonstrating greater efficiency and flexibility in dynamic environments. Among the leading climate control solutions, several notable systems stand out for the use of AI and smart technologies. Like MoMLeT learning thermostat adapts to use the habits via machine learning, optimizing temperature, schedules, and saving energy. It could be a smart thermostat uses temperature and humidity sensors, supports Alexa and HomeKit. Honeywell Home T9 manages multi-zone temperature using external sensors, offering precise control and voice support. Taylor Smart thermostat uses geolocation to adjust temperature automatically when users leave or return, promoting energy efficiency. Daking intelligent thermostat employs AI to analyze and predict climate changes, offering high accuracy, but it's costly and complex to integrate. Oral modern climate control systems increasingly use AI and neural networks to boost efficiency, comfort, and energy savings. Still, each has specific limitations to consider during implementation. This study aims to develop a microcontroller-based climate control system using neural network technologies. The goal is to create an intelligent system for automated monitoring, analysis, and adaptive regulation of climate parameters to maintain comfort and maximize energy efficiency. And as you see, these existing approaches, classical regulators, fuzzy logic, and neural networks will be analyzed for the strengths and limitations. Maintaining comfortable microclimatic conditions is constant human need. While the brain naturally processes temperature, humidity, and airflow to make adjustments, modern systems automate this using microcontrollers in neural network. Implementing such a system involves several key stages: initialization, setting up the microcontrollers, sensor interfaces, and communication modules, data collection, gathering, and initially processing sensor readings, temperature, humidity, airflow, data transmission, sending data via communication modules for further analysis, neural network processing, determining thermal comfort levels from the collected data, decision making, automatically adjusting climate control devices and adaptations. The network refines its parameters to enhance control algorithms over time. One of the key stages in system development is the application of an object-oriented approach, which allows logically structuring the entire system into a unified model. The use case diagram shown in Figure 1 illustrates the relationships between actors and use cases. An office worker can input personal climate preferences and monitor the current microclimate status. The administrator has additional capabilities, including configuring the neural network, adjusting system parameters, and remotely monitoring its status. The sensor system is responsible for collecting the data necessary for making management decisions. The class diagram illustrates the system structure at the class level, including the attributes, method, and relationships. It helps clearly define the types of objects that exist within the system, their properties, and how they interact with each other. The class diagram outlines the architecture of the climate control system, comprising key components with the distinct roles. In the case of the system, the sequence diagram shows how sensor data is transmitted to the microcontroller, where it's processed by the neural network. The results are compared with the expected values, and based on the comparison outcome, a control signal is generated to adjust the climate control devices. This allows for precise identification of when and how the system's operation will be corrected. A central element of the climate control system is the neural network training using the R backpropagation algorithm. The approach ensures accurate regulation by minimizing prediction error while keeping computational demands low, making it suitable for microcontrollers. The system uses a predicted mean load index calculated via Fenger's equation to evaluate terminal comfort on a 7-point scale from very cold to very warm. It also incorporates the predicted percentage of the satisfied PPD index to estimate the proportion of people likely to feel discomfort. This indicates indices are correlated with optimal comfort, typically achieved when PMV ranges between minus 0.5 and plus 0.5 corresponding to PPD below 20 persons. The neural network processes PMV and PPD data to adaptively control the indoor environment, providing personalized comfort while maintaining energy efficiency and user satisfaction. An effective method for predictive climate control is the neural predictive control NPC, which focus some system states using neural network-based empirical models. This approach considers the interconnections between microclimate parameters, enabling adaptive system adjustments and optimizing control actions within allowed limits. The NPC operates based on past state variable values, selecting the best trajectory for changes while respecting device constraints, ensuring efficient and precise climate regulation. The next step was modeling the main stages of the system operation using the algebra algorithms apparatus. As a result of using the properties of the algebra we subtract the common unit in terms by the sign of the eliminations operation and obtain the following formula of the algebra algorithms. According to the processed model, the first stage is the initialization of the system, which includes setting the clock frequency of the ATmega32 microcontroller to 8 MHz, configuring the timers for processing, delays, and interrupts, setting up the I2C interface for communication with the sensor, and initializing UART for communication with the GSM module. In the lab center electronic test environment, a data monitoring subsystem was developed featuring a 5-volt transformer power supply and an 80 MegaHz microcontroller and CHT29 sensor and SIM 900D GSM model. And LCD display show measurement results, while LEDs indicate threshold branches, green for humidity, red for temperature. Simulation of the system provides data for training a neural network. The control subsystem uses the PMV index limited to the range of -2 to +2 and access to ISO 7730 standards. The results of the network training is shown on the slide. The implemented the adaptability of the system is necessary to modify the optimal values, which is done through the system performance assessments by office workers. As seen from the graphs, the desired errors of some parameters was achieved after 2,139 iterations. The training, testing, and validating graphs are shown on slide. To verify the system functionality, we will run the created model and display the graphs of measurement and control parameters as well as PMV index. And as a conclusion, the research resulted in the development of microcontroller-based climate control system utilizing neural network technologies. Traditional methods like PID controls were found limited in adapting to dynamic conditions, while neural network significantly enhanced system efficiency. The system optimizes monitoring and adaptive regulation of temperature, humidity, and airflow, predicting climate changes to adjust device operation. Using the PMV index, improved control algorithm optimization, UML diagrams facilitates clear system design and component interaction. The prototype tested in MATLAB demonstrated effective maintenance of comfortable microclimate conditions with minimal energy use. Neural network increased control accuracy and reduced the need for user intervention. Future work will focus on advancing machine learning algorithms, enhancing adaptive control, integrating IoT technologies, and improving climate prediction accuracy through deep neural network to further optimize the system. That's all from me. Thank you for your attention.
Thank you for the presentation. Maybe before the questions will start, I heard you said about individual climate control that every person can set its own parameters. And I imagined how different people in my room and each and every of them will want their own parameters, how it will work. Well, but maybe it's a question for future. Okay, my
Yes.
questions.
Sorry.
It's okay. Well, if no questions, well, thanks for the presentation. Yet again, any questions, you can contact me and I will send all the information for those whom you are interested in cooperation with and or ask the questions in chat. Thanks for the presentation. Thank you so much. And our next presenter is from the colleagues of Vasil Tesluk, Irina Hado, and Bogdan Filipchuk. I saw Bogdan recently. Yeah, I can see it. Yeah. And you will present the paper on methods and tools for automated adaptive traffic light control based on computer vision. Take the floor.
Yeah, that's all right. Yeah. Please tell me if you can see the screen.
Almost. And yes, we can see it.
Okay, that's fine, sure. So hello everyone. I am pleased to present our joint research titled Methods and Tools for Automated Adaptive Traffic Light Control based on computer vision. This work was carried out by Vasil Tesluk, Irina Hadyo, Bogdan Filipchuk, and Andrei Koval from Lviv Polytechnic National University. In this project, we propose a novel vision-based system for adaptive traffic signal regulation, grounded in formal modeling and engineered for real-time responsiveness in constrained urban environments. Urban areas are facing growing problems related to traffic congestion, delays, and increased air pollution. Fixed timer traffic lights are inadequate for today's dynamic conditions, and existing adaptive systems are often expensive, infrastructure heavy, and not scalable in countries like Ukraine, especially under wartime pressure. We address this with a lightweight vision-based approach that combines real-time adaptation with practical deployment feasibility. Our objective is to develop a scientifically grounded model for automated adaptive traffic light control based on computer vision. The system detects vehicles in real time using a deep learning YOLO model, determines the optimal green phase duration through a formal algorithm, and sends control commands with low latency via WebSocket. Rather than relying on simple rules or reactive behaviors, we focus on structured decision-making and continuous real-time responsiveness, which together forms a consistent and adaptive control strategy. Our key contribution is a mathematical model for dynamically allocating green light time based on vehicle counts, constrained by configurable thresholds. We also propose a hybrid distributed architecture that blends Python-based AI detection with deterministic .NET backend logic. The system is containerized and modular, with WebSocket as a primary communication layer, and automatic fallback to HTTP, ensuring robustness under network instability. Traditional systems like SCATS, the Sydney Coordinated Adaptive Traffic System, or SCOOT, the split cycle of optimization technique, rely on inductive sensors and predefined logic. These solutions are often costly, rigid, and challenging to adapt or scale. Meanwhile, open source alternatives typically emphasize detection, but lack robust decision-making infrastructure or formalized control models. In contrast, our system integrates high-precision vehicle detection with flexible, configurable logic and reliable two-way communication, resulting in a hybrid architecture that offers both scientific novelty and practical value. Here's how the system works. Live video feeds from traffic cameras are processed by the YOLO detector, which extracts vehicle counts. The data is sent via WebSocket or HTTP to a .NET-based decision engine that computes the appropriate green light duration. Traffic signals are updated accordingly. The message with the green light duration for the current cycle is sent via WebSocket with a to the client responsible for controlling the traffic light at the given intersection. For administrators, there is an admin panel where users can monitor and reconfigure the system through a web interface built in React. All components are modular and run in Docker containers for easy scaling and deployment. We used Python for the vision module and YOLO version 11 for real-time object detection. The backend is built with .NET Core and handles decision logic and API access. React powers the admin panel, and WebSocket is used for real-time communication. Detection logic filters out unreliable outputs by applying a confidence threshold. Only objects detected with a confidence score of 0.7 or higher are considered valid. This improves the overall accuracy of the system. All valid detections within a video frame are counted, producing the real-time vehicle count that serves as an input for determining the green light duration. If this count corresponds to the value in the configuration table, that predefined duration is applied. If not, the system calculates the duration by multiplying the vehicle count by standard time per vehicle parameter. To ensure the result remains within the safe operating limits, the final green time is claimed between administrator-defined minimum and maximum bounds. At the heart of our system lies a continuous data-driven control loop. YOLO version 11 processes the video frames, and a message with vehicle count, camera ID, and timestamp is sent to the backend via WebSocket or HTTP request. This real-time loop forms the core of our car detection process. The system consists of 4 core components: the client-side detection module, the backend decision logic, an administrative web interface, and the database. A real-time communication between the detection module and the backend, as well as the backend and the traffic light controller, is implemented via WebSocket to minimize latency.
I'm sorry, but I'm still. Is it only me on the component interaction?
Yeah, that's right. All right,
Yeah.
show you.
Okay. I'm
right
really sorry.
Yeah, that's fine. Thank you. So to continue, real-time communication. So real-time communication between the detection module and the backend, as well as between the backend and the traffic light controller, is implemented via WebSocket to minimize latency. In case the WebSocket connection fails, the detection module automatically falls back to HTTP to preserve system continuity. The admin interface communicates with the backend exclusively over HTTP. This architecture ensures performance and reliability for critical operations while maintaining simplicity in administrative functions. The module structure supports easy scaling and future extensibility. We tested the system using real video data in a simulated environment. WebSocket consistently showed lower and more stable latency than HTTP, which remained acceptable as a fallback. These results validate our communication approach for real-time systems. There are, of course, some limitations. the system depends on a stable connection between the detection and the backend modules. WebSocket interruptions must be handled reliably, and scaling to larger networks may require additional optimization on the server side. But our design already anticipates that through containerization and service isolation. Looking ahead, we plan to integrate pedestrian detection to improve inclusivity, particularly for people with mobility challenges. We also plan to extend the system with modules for traffic forecasting and integration in smart city platforms. The architecture supports such expansion without reworking the core logic. To conclude, our system presents a lightweight, scalable, and adaptive solution for traffic light control. It integrates real-time vehicle detection with responsive decision-making, ensuring both accuracy and efficiency. The hybrid architecture combines the flexibility of AI-based detection with the robustness of a structured backend engine, delivering the best of both approaches. With a modular design and reliable fallback mechanism, the system is ready for pilot deployment in urban environments and provides a solid basis for continued scientific exploration. Yeah, thank you for your attention, and you're welcome to ask any questions.
Yes, thank you, Bogdan, for the presentation. And while the questions are being prepared, I have a question. You mentioned the difficulties. No, can you go to the actuality slide or something? This at the very beginning, second or third.
Yeah,
I just
slide, yeah.
In here, yeah, probably here that you mentioned the difficulties of wartime. What exactly difficulties of wartime you mean? I'm not good in your subject area, just for my wider experience, to widen my experience.
So when I mentioned difficulties like wartime infrastructure pressure, I meant there is some difficulties in implementing like new technologies or infrastructure in some areas, and traffic is one of these areas, like urban infrastructure in cities. So there is also a budget limit, and we show a system that can easily be integrated with like low cost, because all we need is just a server side to calculate our to like detect like vehicles, to calculate the green light duration, and a camera to be in the intersection.
Okay, but the wartime from the point of view that we are lack of money is
lack of money also. Lack of money, and as well, I mentioned the lack of like people that can like implement this solution on the site. Yeah.
Okay, I see. Thanks a lot. Yeah, maybe more questions for Bogdan? If no question, thank you for your presentation. It's the on-time research and interesting. Thanks so much. Okay, and now we are going for the next presenter. Let me see, Igor Chushchak, Vasil Andronik, about the modeling on AI-driven adaptive learning platform for students with special education needs. I can see you, Igor. Yeah, the floor is yours, and I can see your first slide.
Thanks. Hello, everyone. I'm glad to congratulate all participants of the conference, and I would like to present research on the topic modeling an AI-driven adaptive learning platform for students with special needs. Let's get started. The need of equitable, high-quality education has spurred the rise of the digital platforms that use generative AI to create personalized and refined learning experiences. The technological shift aligns with global initiatives to promote social inclusion and to comply with international standards on accessibility and equal rights in education. The exigency of addressing diverse learners' requirements, spanning cognitive and sensory supports to highly adaptive instructional methodologies. drives the need for robust, meticulously modeled information systems. From a systems engineering perspective, designing an educational platform for learners with special educational needs involves managing multiple layers of complexity. Adaptive learning is an innovative educational approach that leverages technology to personalize instructional materials and methods according to the individual needs of each learner. This approach has gained particular relevance in the field of inclusive education, where students with special educational needs require tailored support that addresses their cognitive, emotional, and sensory characteristics. Thanks to recent advancements in artificial intelligence, it is now possible to design adaptive platforms capable to dynamically adjusting educational content in real time. These intelligent systems analyze diagnostic data, track students' performance, and respond behavioral changes, ensuring that learning pathways remain relevant and effective. In Ukraine, there is a growing recognition of the need to update educational environments to better serve students with disabilities. The integration of AI-powered adaptive learning platforms marks a significant step toward providing high-quality, individualized education to all students, regardless of their specific challenges. The goal of this work is to model an AI-powered adaptive learning platform that provides individualized instruction for students with special educational needs. The platform must continuously process 4 key streams of information: diagnostic data that outlines the learner's cognitive and psychophysiological profile, contextual information such as classroom environment and available support, the student current educational goals, and real-time feedback on engagement and performance. Together, these elements form a comprehensive snapshot of the learner states. Based on this snapshot, the platform must then select the most appropriate action from a set of AI capabilities, including content simplification, multimodal media generation, task sequencing, and real-time alerts. The chosen action must advance the learner's educational objectives while adapting to their specific condition and context. Each decision is followed by system-level feedback, evaluating learning outcomes, emotional engagement, and psychosocial well-being. This feedback is essential for updating the platform decision-making policy, ensuring the future actions generate greater value. The core challenge, therefore, lies in designing a system that can continuously learn and refine its policy for mapping complex and variable learners' data to effective strategies promoting long-term progress. This slide presents the use case diagram, which illustrates the full range of interactions between users and AI-driven learning platform. The diagram formally defines permissible sequences of action that take place with the boundaries of modeled educational environment. Each actor in the system, including students, parents, teachers, institutional administrators, and AI agents, interact with the platform by contributing to or receiving outputs from a series of processes. These processes include psychophysiological testing, pedagogical diagnostics, the development of personalized learning objectives, and the creation of individual learning plans. The platform integrates data from multiple stakeholders to assess progress, personalize resources, and continuously refine educational strategies. Notably, it is also features feedback loops such as analysis of AI assistant performance and learning outcomes, which help improve decision-making, the overall effectiveness of learning environment. This diagram represents the UML activity model, which outlines a step-by-step adaptive learning workflow for a student with special educational needs. The process begins with the acquisition of initial psychophysiological assessment results, with then used to survey stakeholders and generate a comprehensive digital profile of the student. Following this, the adaptive AI agent configured and begins generating personalized recommendations. These outputs inform the update of student individual learning trajectory, and during the learning process, digital support is provided in real time, while formative assessment results are collected to track progress. Post-session analysis involves identifying specific challenges in communication, social behavior, and academic achievement. These observations are aggregated into a central analytical repository. The system uses this repository to refine its recommendation algorithm, ensuring continuous improvement. This slide presents a formalized model of the inclusive educational process for individuals with special educational needs using mathematical abstraction of Petri nets. During the analysis of educational workflow, several core functional stages were identified. These stages are characterized by structured sequences and the need of synchronously executed tasks. To model this complexity, we apply the Petri net formalism, which enables both graphical and analytical representation of processes. The Petri net is defined by sets of places and transitions, which correspond respectively to conditions or states, and to the action or events that trigger changes within the system. This approach allows for the clear mapping of dependencies and timing of instructional activities. In this model, transitions denote achievements of specific educational objectives, while places represent the necessary preconditions for these objectives to be fulfilled. Figure 3 illustrates the Petri net, modeling the learning path as a system of interconnected steps that collectively support personalized development of students with special educational needs. This slide presents a comparative performance analysis between traditional learning management system of an AI-driven adaptive platform. The consolidated dashboard synthesizes key educational indicators highlighting how AI integration transformed learning outcomes. First, we observe an increase in the mean post-test score from 71% to 80%. This improvement is attributed to the platform's ability to dynamically adapt content to each learner's knowledge gaps, thereby enhancing comprehension and retention. Second, the course completion rate rises significantly from 70 to 90%. Adaptive learning pathways combined with real-time feedback help students to stay motivated and track with a clearly defined achievable objectives. Finally, the average daily on-task engagement increases from the 32 to 41 minutes. This is driven by personalized prompts and interactive content that main students focus and encourage the active participation. Together, these results underscore the effectiveness of the AI adaptive platform in promoting higher learning efficiency, engagement, and retention compared to the conventional system. This slide, upon comparative data presented earlier, confirming that AI adaptive learning platform outperforms the traditional LMS across all observed dimensions. To quantify how real-time personalized contributes to learning success, a multiple linear regression model was constructed. The equation models post-intervention performance based on a pre-test scores, adaptability of the AI system, and daily engagement minutes. The regression results confirm that each of these variables has a statistically significant effect. The adaptability coefficient is particularly strong, suggesting that AI platform ability to personalize instruction is the most influential factor in boosting learning outcomes. In conclusion, this study confirms that developing an inclusive educational informational system driven by an integrated AI system marks a significant step forward in delivering an equitable, high-quality learning experience for students with special educational needs. The proposed framework integrates regulatory compliance, adaptive pedagogy, and cutting-edge technologies such as generative AI, reinforcement learning, cloud infrastructure, and privacy-preserving analytics. Though these model educational pathways become fully personalized, continuously adapting in real time to diagnostic data, learning context, and ongoing performance feedback. By embedding these capabilities with the reinforcement learning paradigm, the system not only addresses immediate student needs, but also evolves intelligently, aligning instructional strategies with individual learning profiles. Ultimately, this work presents a scalable and resilient foundation for future digital learning ecosystems, systems that are inclusive by design and personalized by function, ensuring no learner is left behind in the digital education landscape. Thanks for your attention, and please feel free to ask any questions.
Yes, thanks, Igor, for the presentation. Yep, please, questions, if any. But
So I have
okay.
a small question. So you've shown the slide with results where you compared the AI approach and non-AI approach. So I'm just curious, how were the data of this comparison collected? Where did they come from?
It was compared on the data that was found inside the World Wide Web regarding non-AI platform, and the results from AI adaptive platform were taken from my investigations. I have taken some middle known factors and compared with the traditional one.
Okay, thanks for your answer.
And to continue the question, so do you have this AI adaptive platform? You have developed it?
It is currently in the development state, but I think in the closest future it will be finished, and we can try even to use it.
Well, but maybe it's too early to show these results. Yes.
Generally, AI is already integrated inside that platform, but the rest part of platform is not ready yet.
Okay.
We can work just with the AI integration and see how it recommends and works with it inside with the data.
But you have this course completion rate. So the course you suggest was completed. If you the second line.
Yep, you can complete course, but the platform itself is missing like a UI, final UI state. So mainly everything that is related like to the engine of this platform is ready, just left to put it into the some beautiful body with the UI, I mean.
Okay, but yeah, this question I have, you said here, students spend 41 minutes per day actively working in the adaptive environment. So you have those students. So where did you get those students? You said are those students with special needs? Yeah. Well, where did you get those students? How did you manage to work with them, with the students of special education needs?
I have found during using World Wide Web a few students and one group of them, and asked just to try from their side if it's worked for them well. And they returned me some results.
I see. Okay, thanks a lot. Well, maybe. Well, you named your work modeling this AI platform. Maybe it's better to name it that you have something that you already received the results. It's more powerful, I think. Just modeling, maybe. But it's just to consider because. In my head, modeling is the begin initial stage, and then the results you obtained. It's if you already work with students with special needs, it's enormously more interesting and powerful. But it's up to you, Igor. Thanks for the presentation. Maybe more questions. Again, well, you can contact me, and I will give these questions to Igor and his co-author. Thank you, Igor, for your presentation. Thank you so much.
Thank you.
Next presenter, just a second, additional advertisement is just horrible. Am I right? Andriy Burkov, Vladislav Alexey. Oh, Andriy Holovko, hello, I can see you. Definitely,
I
it's you are the
started
next
sharing
presenter.
already.
Yeah, I can
just
see.
let me know if you can see my screen.
We can see both you and the presentation. Yeah, take the
And the
floor.
presentation. Okay, fine. It's good. So, good morning. Good morning, everyone. First of all, it's great to be here at this conference. So I'm Andriy Holovko, a co-author of paper Syntax-Aware Tokenizer for Go Code Style Analysis. We prepared that paper together with Professor Andriy Berko and my advisor, Vladislav Alexeyev. And in today's presentation, we will explore how making large language models more aware of syntax semantics can be beneficial, but also can have some unexpected challenges. So let's dive into our work. We all know consistent code style is vital for readability and collaboration. It improves code quality, helps to reduce errors, and increase our efficiency. And we use tools like GoFMT and GoCritic to assist us with keeping our code consistent. These tools help us to follow established style guide easier. But what about those nowadays famous large language models? So nowadays they're used a lot in software development, but the question is, can they truly grasp and enforce style consistency in our code? So our research explores one way how to make these large language models better at this specific task. So we decided to start with the first step, and it's about tokenization. So tokenization is the first step how these models see our code. So actually, standard tokenizers often treat code just like regular text. They break it into tokens without, without keeping structural context. So, for example, let's look at the default Llama tokenizer that is based on a tick token and implements byte pair encoding. So, this tokenizer would split the following sample code into 19 tokens without any hint what is the role of each token. But code isn't just text, it has inherent structure, and we can capture it using, for example, abstract syntax trees. So our idea is the following. What if we give the LLM this structural information? Could a syntax-aware tokenizer improve detection of style violations in Go code? So actually, to find this out, we built a tokenizer that is aware of syntax and semantics of Go code. Instead of just splitting code into meaningless subword tokens, our tokenizer uses special tokens derived from abstract syntax tree, like like identifier, different kinds of literals or comments. So you can see how it works for the sample code on this slide here. The goal is to give our pre-trained Llama model more structured view of Go code and help it to identify common style violations. So for testing our idea, we prepared a dataset with more than 2,200 Go snippets. Each snippet has one or more violations that checkers from the style group can find. We selected 8 of them. So like 8 violations. They are listed here in this table, and most of them are enabled by default and are considered non-opinionated. So it means that majority of Go developers would agree that they improve code style. So these checks generally suggest replacing some form of expression or statement with another one that is considered more idiomatic or simple. So we should also mention that in our dataset, which is based on real code, there are very few snippets with more than 2 violations at the same time. So it means that result in multi-label target vector would be very sparse, with the majority of labels set to 0. So we took this into consideration when choosing evaluation metrics and sampling approach. So we ran actually 3 experiments and training our model a bit more each time. For the first experiment, we did a lightweight training. In this step, we only adjusted the part of the model that made the final decision. This is classification head. In the case of our syntax-aware tokenizer, we also updated the embedding layer, so the model can learn new tokens that we added. In the second experiment, we trained, in addition, the last transformer layer, layer 15. And in our last experiment, we trained all of that from the previous steps, plus the final 4 layers. So, and this is like early results for syntax-aware tokenizer. So in that late-wise scenario, where only the classification had an input embeddings were fine-tuned, our syntax-aware tokenizer was a clear winner. So it achieved a considerably higher F1 score on test data, 0.29, compared to just 0.66. Sorry, it's probably this one. Yeah. 0.66 for the standard tokenizer. These results demonstrate that structural tokens provide valuable information for the model and help it quickly grasp the style rules with minimal adjustment to model weights. But then came the twist. So as we unfroze more layers, allowing for deeper fine-tuning, the standard tokenizer started to catch up, and then overcome our syntax-aware variant. By experiment 3, with 4 transformer layers unfroze, the standard tokenized reached an F1 score of 0.7 on test data. Our syntax-aware tokenizer remained at 0.3. Approximately. This can be explained in the following way. So the standard tokenizer benefits more from knowledge that is already built into the model, but our new tokenizer needs more training or better methods to fully use that pre-trained model from deeper layers. So actually, what lessons we learned? So the main lessons of our research is the following. So if you can only do limited fine-tuning, for whatever reason, a syntax-aware tokenizer is a better choice. But if you can afford deeper training, use the standard tokenizer because it takes full advantage of what the model already knows and performs better after fine-tuning more layers. So actually, what next for us? We plan to keep exploring better ways to help language models analyze code style. So we want first to improve how our tokenizer maps the code structure to syntax-aware tokens. Second, to optimize the fine-tuning process by using better techniques and specialized loss functions. Third, to enhance embedding integration by training embeddings only for newly introduced tokens instead of retraining the entire embedding layer. And fourth, to improve handling the real-world cases where code isn't always perfect and sometimes fail to parse or has compilation issues. So that's it for today. Thank you a lot for your attention. And our code and dataset are available online, so you can scan these QR codes and reach to the appropriate resources. And we are also excited to share our full paper soon. So if you have any questions, so I'm glad to answer them.
I'm just a question. Not supposedly, as it always was, this conference paper will be shared in an open access. Will those QR codes or those links be there in your paper?
So yes, we have actually it would let me maybe show you how it would look like. So actually, can you see my screen?
Not yet.
No, probably because I shared just presentation. Let me switch to sharing application window. Do you see it?
I can see the conference program. Yeah, now I can see the paper.
So this is actually paper, and this here we have just something like that, right?
In
So
here.
we have a link. Yes, so we have a link to our sort of implementation, and we also have links to our dataset.
I see. Thanks. Thank you so much. Yeah.
Source code is available on GitHub, so it's free.
Okay.
Yeah.
Thanks. Thank you so much. Thank you, Andrei. Thank you very much. So maybe colleagues' questions? Okay. What will be your next step, Andrei? How do you feel to continue your work? What's
first of all,
next?
we would like to improve, as I mentioned, those mapping. So because initially it was like, again, so it was very basic implementation, right? So we just get some syntax, right? So it's, for example, you can see it here, right? So we have indentation, we have then, okay, some name of function. Then we have another, like not indentation, but identifier. Then we have another identifier. But actually, we still miss some important information. For example, this one, right? So it's not just any like identifier, it's specifically name of package, right? So it can be captured better probably in that tokens. So this is probably one way where we can improve code. We also spend quite a lot of time on optimizing, right? So this is like fine-tuning procedure. It requires quite a lot of resources. This is, by the way, the reason why I asked others about computational resources, because it's quite expensive and you know, it requires ordering some computational from cloud providers. And but because it was very sort of basic implementation, it was not well optimized. So it might be the next step. And also probably again, so when you are using abstract syntax trees, right? So your code should be valid. It means that it should be parsable. And it's a huge limitation, because usually, especially if you would like you know, like to include those models in your IDE, when when you type code and you can sort of get hint. Usually your code is not complete, right? So it's still like it's not parsable, and it might have a problem with being represented as abstract syntax trees. So probably we should have some additional solution to that particular cases. So this is like another area where we can sort of improve. Yes, exactly.
I see. Thank you. Yeah, I see. Well, the computational. Yeah, we have faced this problem of computational resources. Indeed,
actually,
it is
for me, for the whole paper, I spent around $100 for that ordering, like for renting, I would say, computational resources. So it's not a lot, but still. So we would like, like if you would like to make it more portable, I mean, like those contacts code suggestions, right? So you would like to be able to run it locally, right? And it might, it might be a problem if it requires a lot of resources. So we should think about optimization for sure.
It's the money question very often. Yes, thanks a lot, Andrei, for the presentation. Hope you will find someone to support financially your work.
Maybe in form of some startup.
Okay. Yeah. There was a question from someone.
Yeah. So I have a small question. So first of all, thank you for this great presentation. And I just want to ask, your tokenizer works in scope of one file only, or does it grasp a whole file structure, like placing it into some meaningful blocks and finding what exactly like should go to AI from this all file structure? All related blocks in the whole
actually
project?
it works along with standard tokenizer. So this is sort of how it was implemented. So it was like pre-tokenizer step, I would say, right? So like usually, so when you give some text to the LLM, so tokenizer is the first step that get the text, right, and tries to make sense of it, right? Not make sense of it, but actually split it into numbers, right? To send it to the model, to the next layer. So in our case, it was like pre-tokenizer step, right? So we get so it was like a wrapper around that standard tokenizer. So we get the input initially, we add those like syntax specific tokens to existing one, and then we send it to the standard tokenizer. So, and then like model started to do its routine, right? So what it was designed. So yeah, so this is how it worked. And does it answer your question?
Yeah. Thank you.
So yeah, sort of.
Okay. More questions for Andrei? If Not well. Thanks for the presentation and for the discussion. Thanks a lot, and all the colleagues. Thanks for discussion. And we have to we can now move forward to the next presenter. It's I saw Danilo Prot. Am I right? Yeah, I can see you.
Yeah,
It's
that would be
but
me.
Danilo will give a speech on the end-to-end development of a retrieval augmented large language model for cloud-based healthcare applications. So Danilo, the floor is yours.
Thank you. Can you see my screen?
Yes, very nice.
Okay, so hello everyone. We are excited to present our work on building the end-to-end system that uses a retrieval augmented large language model, or RAG-LLM, for cloud-based healthcare. The goal is to support both patients and doctors with faster, more informed communication and diagnosis. So our main goal is to make the doctor-patient relations easier and more efficient. The system helps patient understand their condition with the help of AI, while providing doctor with a structured summary and relevant supporting documents. Our research object is the overall cloud-based system. The subject is more specific. We investigate how to use retrieval augmented generation to boost the performance of language models in medical diagnosis. So then about the scientific novelty, what's new in our approach is the complete end-to-end integration of multiple AI technologies. First, we use convolutional neural networks, or CNNs, to process and classify medical images. Then we add context to it, like the data that user shares in questionnaire of our app, and then like providing the data like in chat system describing their problem. Then we add context, an explanation using the large language model that's been enhanced with RAG mechanism. Our vector database includes medical articles and drug descriptions scraped from trusted sources like Mayo Clinic and RxList. And all components are hosted in the cloud using Amazon Web Services or AWS, making the system scalable, secure, and efficient. So how RAG works, let me briefly explain how our pipeline is set. So unlike a typical language model that relies only on its training data, RAG systems combine generation with real-time document retrieval. In our case, the model takes the CNN result and patient input and then retrieves the relevant documents such as medical articles or treatment summaries from a vector database. And these documents are embedded as a context and fed into the language model, which then generates an explanation grounded on these medical facts. This makes the AI more reliable, factual, and less prone to hallucinations. So this is the highest level of our architecture and the whole data pipeline works. So basically what we have here, the user uploads the photo. It goes to, our server. It goes to the S3 storage with some kind of infrastructure. Then the Lambda event coordinator is triggered, and this photo is fed up to one of our CNNs. CNN then classifies the image that gets into it and uploads the result back to S3. One more time, the Lambda is triggered, and those data from classification of CNN and other data from chat of user and user personal data is fed up to LLM or RAG. And then it retrieves related documents from this classification result. Like, for instance, we have a patient that uploaded an image of eczema. And our CNN detected that this is an eczema. And we have a top one condition that it is. And related documents from our vector storage are fetched about eczema, about medical treatment for this disease. And so this forms a single prompt to our model that constructs a response. And then this response is one more time uploaded to S3. And via WebSocket connection and server, we are showing it into UI But here is the catch. We are showing it not to a user directly because we are working with medical healthcare domain. So we cannot be 100% sure all the time about how the model will work in this case or this scenario. So we are integrating the doctor in this system. So we are just making like an assistant for doctor for easier understanding and minimize time for like answer. So doctor verifies this answer and then chooses to correct it or not and send it back. So this is it. And yeah, those are the use cases. So let's walk through the real world example. A user opens our application, uploads a photo of a skin issue, and optionally describe the system. The CNN model analyzes the image and gives a prediction, say eczema. Yeah, this prediction is passed to the RAG model, which fetches relevant clinical details about eczema from the vector database and crafts a user-friendly explanation. Before anything is shown to the patient, the doctor reviews it, adds recommendations, and confirms or just adds the final message. This preserves clinical accuracy while empowering the patient with useful insights. So let's now look at the system from the doctor's perspective. When a doctor logs into the secure dashboard, they are authenticated using AWS Cognito. Immediately, they can see new incoming cases. This consists of medical image, short patient symptoms, and the AI's proposed response. The response is generated by our hybrid AI pipeline. CNN provides generally those pipeline that I described earlier. So, and then user is able to communicate with, doctor is able to communicate with user using our chat, and that's how it all works together. So this is some snapshots of our UI made for this. So you can see a chat with the user, how he uploads a photo. There are some snippets. And for doctor, the proposed answer by AI assistant would be looking something like that. So he can like correct it, make it better, and send it to user. Also, for like I want to mention in this slide, so for collecting our data on approval of doctors, we are also enabling doctor to send a feedback whether this response was good or not. And based on those doctors' answers, we are actually retraining our models. Like this response was not relevant at all, so we need to retrain on this data. And we are just classifying those answers as only positive, and only positive are becoming a new data set for retrain. So that's it. And about key takeaways, to summarize, the system supports both patients, doctors by offering fast, explainable, and medically grounded assistance. The architecture is scalable and could be extended to more medical areas beyond dermatology and ophthalmology. And that concludes the presentation. I would be more than happy to answer all of your questions.
Yeah, we have a question from Andrei. Thank you, Danilo.
Yes, actually, I have a question. So first of all, thank you for sharing and for such a great presentation. So it's really nice. So my question is actually, is it just proof of concept or it's already like application in production?
It's not in production. It's still in development, but we are actively taking part with doctors. So we are really like inviting doctors to use our app a bit, and we are like collecting their feedback, what can be improved and what should be made to make it better.
So
Yes.
looks like that you are using human in a loop strategy, right? So
yes.
Okay, and speaking about doctors, what are the initial feedback?
For now, they
Does
are
it
like
help them? I mean,
yes, it makes because for now, like there are such a lot of patients in clinics that are just with not such strong cases, but they need to be responded. So this AI assistants just make it easier and faster. You can just briefly look for this response and click on send, and yeah, that's conclude. But if there is something like more serious, for instance, psoriasis or other things, or basal carcinoma, the model would recommend an instant doctor appointment to like better vision of this problem. So yeah,
Like
we
sort of
are
red flag alert, that kind of stuff.
yeah.
I see. So yeah, very promising product, and you can earn a lot of money, fortune from it, right? Yeah,
Hope
thank you.
so. Thanks.
Okay, and thanks for the question and for the reply, Danilo. Can you go back to the use case diagrams?
Yes, sure. Which one? For user
then,
or for doctor?
the next one.
Okay.
Well, it will be connected to both of them, but this one is more obvious. You see, as much as I was taught, in those not circles, there's supposed to be some verbs like registration, okay, view, like view patients from the doctor. View patients, receive and edit suggestion, communicate with user. Okay. Communicate these three: view patients, receive and edit, and communicate with users. They are based on verbs. It's in actions. But authorization, well, we do understand it's a process as well, but maybe just rename it, just feel more use case appropriate. And in this case, those pink with LLM and sub base, I have never seen nouns in those ovals.
So that's nouns because that's actually a name of technology that extends and that is used for this current process.
Yeah, I understand, but there's not supposed to be nouns in use cases. Maybe use or apply this model or something like this, but no, just make sure it's according to standards. That's the only, and it's for both these and the previous diagram use case as well. Yeah, interaction. It's in this the last one for the system interaction via WebSockets. Yet again, in my head, it's just like a noun group, not maybe interact with WebSocket via WebSocket. Maybe like this. Just make sure how to present it according to standards. That's it from my side. Well, maybe more questions for Danilo. Okay. If no, thank you so much for the presentation. Thank you for your work. Hope it will be finished. Oh, I can see Rostislav Urinets. As much as I know, it's the last representative of our last speech on forecasting credit risk using multi-nominal logistic regression. Rostislav, the floor is yours. You can share the screen. Almost. Yes, we can see the PowerPoint. Okay. Now we can see the first. Okay, very good.
Minimal logistic regression. The article evaluates and forecasts credit risk. The proposed multinomial logistic regression model allows to evaluate and forecast the credit risk indicator of financial institutions, taking into account various factors. Multinomial logistic regression allows financial institutions to classify credits into multiple classes, providing a more granular view of credit risk that better reflects the complexity of real-world lending outcomes. Multinomial logistic regression works by modeling the relationships between predictor variables, and a categorical outcome variable is multiple possible classes. The model calculates the probability of an observation belonging to each possible outcome category, with these probabilities summing to 1 across all categories. This multi-class capability gives multinomial logistic regression significant advantages in credit risk scenarios where credits might need classification into several distinct risk tiers. For credit risk assessment, a relationship should be established between factors and probability size of credit risk. We will take the credit risk indicator according to 3 values: satisfy, partially satisfy, and not satisfy. The following factors were used in the study: average monthly income, sum of the credit, term of the credit, interest rate, age, expert assessment of the professional, economic, and social status of the client. Multinomial logistic regression makes it possible to consider the probability that a risk will be classified as a certain group risk. The coefficients of the model are estimated by numerically solving the plausibility equations. The solution of this system is carried out numerically using the Newton-Raphson method. The evaluation of client solvency by the model of multinomial logistic regression in the presented paper required the statement of correlation between risk factors and probability size of credit risk. Table 1 presents a matrix fragment of values of 9 indexes which were selected during the analysis, in which a variable y describes the following situations: 0 is no credit provided, 1 is credit provided, 2 is partially credit provided. The parameters of the obtained multinomial logarithm model are provided in Table 3. The analytical expression for the constructed multinomial logarithm model are following the resulting expression can be used to estimate the probability of credit risk for different values of factors. In particular, figures 1 and 2 show the dependence of the studied indicator probability of granting credit to customers on the change in the factor average monthly income for certain values of the factor sum of the credit and fixed values of the other factors. When the requested credit amount increases, banks typically face higher credit risk due to greater potential losses if the borrower defaults. This leads to a decrease in the probability of granting the full credit amount outright. Instead, banks often increase the likelihood of granting a partial credit amount as a risk mitigation strategy. This approach helps limit exposure while still serving the borrower's needs.
Rostislav, are you with us?
Figures 3 and 4 show the dependence of the studied indicator on the change in the factor average monthly income for certain values of the factor age and a fixed value of the other factors. Figures 3 and 4 show a decrease in the probability of granting a credit and an increase in the probability of partial granting a credit due to increasing age. This is due to the fact the lenders consider age as a risk factor, especially when the candidate's age on the date of full fulfillment of obligations under the credit agreement exceeds a certain threshold. Multinomial logistic regression demonstrates considerable value in credit risk modeling, offering a balance of predictive power, interpretability, and multi-class classification capabilities. Multinomial logistic regression is relevant for credit risk modeling due to its versatility in handling multi-class scenarios, interpretability, and adaptation to ordinal ratings. Studies consistently validate its effectiveness in real-world banking risk assessments, making it a fundamental tool in modern credit risk frameworks.
Rostislav, we lost the presentation.
Yes.
Have you finished the presentation?
Finish.
Okay, I thought maybe some happened. Okay, then maybe there are some questions for Rostislav. I just probably missed the conclusions, so maybe I will ask about the conclusions. So what was the results, and how do you think, how should we continue? How do you think you will continue your work on this subject?
Можна українською, я ще не зрозумів, про що запитується.
То які результати отримали і що ви в майбутньому плануєте робити?
Отже, отримано за допомогою мультиноміальної логістичної регресії отримано ймовірність надання кредиту, часткового надання, не надання або надати кредит повністю.
Окей, добре. А в майбутньому, як розвиватиметься ця тема? Що планують робити далі?
Це можна впроваджувати в банківську систему.
Банківську систему. Ага, добре, дякую. Може ще запитання, колег?
Yeah, I would like to set a question, but should I continue in Ukrainian, I guess?
Yes, please. Так.
Отож, в мене наступне питання. Ваша стаття стосується мультиномінальної логістичної регресії для використання у цій сфері. Чи розглядали ви якісь альтернативи цього методу машинного навчання, тому що це такий доволі примітивний, можливо, щось розглядали інше, як альтернативи, чи порівнювали якісь результати? Дякую.
Даний метод є трошки швидший, якщо порівняно з іншими, і дає досить хороші результати порівняно з іншими методами. Але тут наголос можна зробити на швидший метод. І він також, наприклад, порівняно з нейронними мережами, він відображає взаємозалежність між показниками.
Я також за машинне навчання, тобто, умовно кажучи, якщо ми розглядаємо, наприклад, дерева, бустинг, випадковий ліс, тобто, можливо, ви розглядали якісь з цих методів також, аби порівняти саме не глибоке навчання, а машинне?
В даному випадку інші методи не розглядалися.
Добре, дуже дякую.
Окей, добре, дякую. Ще, можливо, питання? Окей. Окей. Добре, дякую. Якщо немає запитань, то окей, I'll skip back to English yet again. by this last presentation, we have finished all the presentations that we have for today. I'm so glad you joined. I'm so glad you presented your works. I learned a lot. I'm so glad we have such a different object areas and subject areas. So it means that although we have very similar methods, well, it's too loud to say it's similar, but yet again, artificial intelligence and machine learning, and our colleagues, and we can implement it in very wide range of areas of our everyday life. So thank you so much, and we'll be joining back at 11:30 for the round table and closing ceremony. I will say a few words, or maybe and maybe the head of the conference will say a few words, and thanks again for your presentation. Thanks for joining us on this Sunday. And you have Andrei questions. Yeah, please.
Yeah, should we use the same link as
Yeah.
this one?
Yeah, probably the
Okay.
same link from this one as this one.
Okay.
Okay. So see you at 11:30. Those of you who would like to join us. Again, thanks a lot, and see you in about 21 minutes. Bye.
Thank you. See you.
Thank you, and see you.
See you.
Mhm.